Hi guys, this is an AP Calc video 5-13 for Thursday, January 9th. And this, everything up to 5-12 could be on the midterm. But this will not be on the midterm. There will be partner problems like this tomorrow, but I promise I'll make them short so that you can practice for the midterm. Or maybe I'll put some partner problems on that would be more relevant to stuff that would be on the midterm, but this will not be on the midterm. And this is a anti-differentiation technique called U substitution. There is homework with this. This should be a short video, and it's page 21, numbers 1 through 3. The more you do of these, the easier it will become with time. So first we've got to find the differential of U. Okay, so if U is equal to this, the differential is this. It's just du, this is how you find a differential. You just go du equals, and then you take the derivative of this. So I'll go, so it's 8x to the third minus 3, and then you do dx at the end. Okay, so this here to the right, this is the differential of u. Okay, so du stands for the differential of u, and that's what it is there. Okay, so you just do, du, and then you take the derivative and put a dx at the end, and this is the differential. Okay, find the differential of v. So the differential of v is equal to the derivative of this, which is negative sine of t, and then you put a dt at the end. Okay, so that's how you find differentials. And the reason why we're finding differentials is because that's how you use the technique that we're about to. So find the antiderivative of the function below. All right, so this is called U substitution. And I'm going to do 3 examples so you can sort of get the hang of it, but we don't know how to find the antiderivative of this. But if we did a substitution, if we let u equal something, okay, some expression involved up here, then we could take its differential and then do some other substitutions, and this will become something that we know how to take the antiderivative of. Okay, so when you're deciding, guys, what you're going to let u equal, you should look for functions that are inside of other functions. So, for example, I've got 1 minus x squared. That is a function that's inside of that square root function. So I'll let u equal 1 minus x squared. So you find a u. So let u equal this. And you might have to try more than one thing until you get it. But okay, and it's usually a good bet to choose a function that is inside of another function. So this function here is inside of the square root function. And then you take the differential. So the differential of u is equal to negative 2x dx. And then you get the dx by itself, okay, I'm going to divide both sides by this. So if du equals that, then dx equals 1 over negative 2x du. Okay, I just divided both sides by negative 2x. And then you're going to use this and this to substitute into this indefinite integral. Okay, an indefinite integral is an integral that you don't have upper and lower limits, so you're not finding area. An indefinite integral is an antiderivative. You're finding an antiderivative. So this is equal to the antiderivative of 2x radical u, and then what's going in for dx is this. So times 1 over negative 2x du. And the goal here, guys, we will know that we chose the right u if all of the x's cancel, all right? And we're left with nothing but u's. And we did it because those x's are going to cancel. The 2's also will. And we end up with the antiderivative of negative radical u du. Okay? I can pull that negative out front, and this is u to the 1/2. And now I just use the power rule. So this is negative, it's going to be u to the 3/2. Okay, but then I divide by 3/2, which is multiplying by 2/3, plus c. Okay, so at this point I have taken the antiderivative, and remember, when you find an antiderivative, you're not finding a single function necessarily. If they just say find the antiderivative without giving you any conditions, then you're finding a family of antiderivatives. A family of functions, all of whose derivatives are what you were taking the antiderivative of. And then the very last step, guys, is to plug the u back in. So this is negative 2/3, 1 minus x squared, 3/2 plus c. And if you take the derivative of this, you will end up with this function here. Okay, so this thing here is the antiderivative family, because of the plus c, of that one right there. Okay, so we're going to do 2 more examples. Find the antiderivative of the function below. So again, when you're choosing a u, so the first clue that you've got to use u substitution is that you just have no idea how to find the antiderivative of this. We don't have a formula that would give us its antiderivative. We definitely can't use power rule. So then you try u substitution. And you want to let u equal a function that is inside of another function. I see a cosine function, and inside of it, its input is another function, x to the 4th plus 2. So that's what I will let my u be. Then you take its differential. Du equals 4x to the 3rd dx. Then you get dx by itself. So dx equals, I'm dividing both sides by that, 1 over 4x cubed du. And we will know that we chose the right u if when we plug this u in and we plug this in for dx, if all of the x's cancel and we have nothing but u's. So this is equal to, this is a very nice technique, the antiderivative, and a lot of people would say the integral of. Okay, Mr. Romer was really picky about the student, picky in a good way, about the students knowing that this is not an integral. It is, the integral is the area under a curve. This empty integral or an indefinite integral means the antiderivative. So the antiderivative of x to the 3rd cosine of u, and then times 1 over 4x to the 3rd du. And I'll know that I made the right choice if the x's cancel, and they do. So those cancel. I'm going to pull that 1/4 out front. All right, so this is, that's the constant multiple rule. So 1/4 antiderivative of cosine of u du, which is 1/4. The antiderivative of cosine is negative sine, okay, plus c. And then the very last step, I'll do a negative 1/4. And then this is sine of x to the 4th plus 2 plus c. Alrighty. And if you want to take that derivative, you will end up with what we were taking the antiderivative of. So there's that. Okay. Next, find the antiderivative of the function below. So I'm looking, so I can't use power rule on this for sure. And I don't know a formula for its antiderivative, so I'll use u substitution. So I'll let u equal a function that is inside of another. I see a square root function, and its input is another function, 2x plus 1, so that'll be my u. And then I go du equals 2 dx. This is always nice if when you choose the u, not always nice, I guess, but this turns out nice. So we chose the u, its derivative was just a constant. So dx is equal to 1 over 2 du. All right, and now I'm going to plug this u in, and I'll plug that in for dx. And this is the antiderivative of the square root of u times 1/2 du. There were no x's outside of the square root to cancel, so that worked out nicely. And I'm just going to pull that 1/2 out front. This is the constant multiple rule. It works for derivatives, integrals, antiderivatives. if you're taking the derivative or the antiderivative of something, you can pull constant multiples out front of the operation. And then this is the antiderivative of u to the 1/2 du, 1/2, and then this is, it'll be u to the, so 2/3 u to the 3/2 plus c, and then this is 1/3. What is u? It is 2x plus 1 to the 3/2 plus c. Yeah, I normally only assign like one homework problem, but really you just have to get the hang of this. And the only way to do that is by doing a lot of examples. And on the homework, you'll see, guys, I am telling you the u that you should use. In the future, you'll have to decide, you know, what the u is. But for these first three problems, I will tell you. Okay, again, this is an important topic. It's an important technique, and we'll use it a lot going forward, but it will not be on the midterm. Okay. All right, guys, have a great day or night, and I will see you soon. Bye-bye.